to Hello everyone, मेरा नाम संजीव सिजाली currently studying at Software College of IT and E-commerce in partnership with Coventry University. My Software ID is 230524 and my Coventry University is 148111933. I am presenting this video as part of my Viva assessment for the module Data Science for Developers. The aim of this project was to use data science technique to support property investment decision. For this project, all data sets were provided by our teachers and my role was to clean, analyze and interpret the data using R programming. The study focuses on comparing two UK counties, Cheshire and Cumberland, to identify which towns are more suitable for property assessment, especially for international investor who may not be familiar with local condition. Rather than relying on intuition, this project follows a data-driven approach and evaluates location using three key factors: house prices to measure affordability, broadband speed to represent connectivity and support remote work, crime rate to reflect safety and quality of life. These factors together gives a more realistic view of property investment. Data cleaning. A major part of this project involved data cleaning. This includes removing duplicate records, handling missing values, correcting data formats, and mapping postcodes to towns. Data cleaning is essential because unclean data can lead to misleading analysis. By cleaning the data properly, the accuracy and reliability of the results were improved. House prices. House price data was sourced from the UK land registry data provided for the project to avoid distortion caused by extremely high property values. Median house prices were used instead of average. This allowed us fair comparison between towns and helped identify areas that are more affordable while still offering future investment potential. Broadband speed. Broadband speed data was taken from Ofcom dataset. In today's digital environment, fast and reliable internet is critical, particularly for remote work. The data was clean and aggregated at town level, and average data speed was used as the main indicator of connectivity. Towns with higher broadband speeds were considered more attractive and future ready. Crime rate. Crime rate was sourced from UK police and Home Office dataset. Crime rates were calculated relative to population size to ensure fair comparison between towns. Lower crime rates were scored higher as safety plays an important role in liability, community well-being, and long-term property value. Exploratory data analysis and linear modeling. Exploratory data analysis EDA was done using charts and graphs like bar charts, line graphs, plots, and scatter plots to find pattern and trend. We also applied linear regression modeling to study relationship between variables. The results showed that areas with better broadband connectivity generally have higher house price. Areas with higher crime rates tend to have lower property values. This supports the idea that connectivity and safety strongly influence investment decision along with affordability. These are some charts. In this chart, it shows average house prices by town 2022. It's a visual ranking of towns by how expensive their average house was in 2022, showing that prices vary significantly from one town to another. This chart shows average house prices trend from 2022 to 2024. This chart tracks the house price trends over 3 years, showing if prices rose or fell in each county and which one was generally more expensive. And this one is house prices distribution by town for 2023. This box plot compares the range of house prices across various towns in 2023, highlighting the middle market value for each area and identifying exceptionally expensive luxury homes as other outliers. And this one shows the distribution of average download speed for the broadband coverage. This box plot compares the range of house prices across various towns in uh, yeah, yeah. It's a visual report showing that internet speeds are not the same everywhere in Cheshire. Some areas have much faster internet available than others. And these are some extra charts that we got from doing EDA. For the recommendation systems, using 2023 data, or recommendation system was developed. It combines house price with a 40% weight, broadband speed with a 30% weight, crime rate with a 30% weight. Towns were ranked based on combined score, and only towns with enough data were included to ensure accuracy. The result shows that although Cheshire had the top ranked town, many high scoring towns were located in Cumberland, proving that balance factors can be more important than price alone. And for the legal and ethical issue, while working with data sets, several legal and ethical considerations were taken into account. Privacy, crime, and population data may contain sensitive information, so no personally identified information was exposed. Ethics, crime data could create negative perception of communities if misused, so results were presented at a generalized town level. Data accuracy, only verified publicly available data sets were used, and careful cleaning ensured reliable result. Transparency, the scoring method of the recommendation system was explained clearly to avoid misleading investors. This consideration ensures the project is ethical, legal, and responsible. For the conclusion, this project shows how data science can guide informed and ethical property investment decisions. Instead of focusing only on affordability, the analysis shows that connectivity and safety are equally important. The recommendation system provides a clear data driven guide for investors and can be updated regularly as a new data becomes. And at last, for the code, we have broadband cleaning broadband speed. Where for cleaning broadband speed data, I first rename the columns to make them easier to work with. Remove any missing or zero values and filter the data to include only relevant postcode areas. I then aggregated the data by postcode to get average and maximum download and upload speed. This ensures the broadband metrics are accurate and ready for analysis. And for the run, where it is running, and it shows the broadband coverage for the and the broadband coverage filter, coverage clean, coverage summary. And for cleaning broadband speed data, I first rename the column to make them easier to work with. Remove any missing not this. I remove missing values, standardized coverage types, and aggregated coverage information by postcode. This allows comparison of connectivity availability across different areas and provides a clear picture of broadband coverage by postcode, coverage summary. We have this. Cleaning crime rate data. In cleaning crime rate cleaning crime data, I renamed columns, removed invalid records, and aggregated the number of crimes by type and postcode. This process ensured that the safety information for each area is reliable for further analysis. Now it will show the crime data clean, raw data, raw crime data, robbery summary, drug offensive offense summary, cleaning. mm, For cleaning population data, I remove inconsistent or missing records and aggregated population figures by postcode. This provides accurate demographic context for per capita calculation and on other analysis. Now it will show top 15 districts with postcodes, population raw, population clean, and for the EDA, during EDA exploratory data analysis, I visualize the dataset using graphs such as box plot, histogram, and bar charts to explore distribution trends and relationship between variables. These steps help identify patterns, detect outliers, and support insights and making decision. This is the code, and I will be running this code. Now it will give us some charts. The charts. These are the charts that we got from doing EDA. This we have like about 23 charts. Population by region, overall score, component. And for the linear modeling, for the linear modeling, I examined correlation between house prices, broadband speed, uh, and crime rates, and fitted regression models to understand the impact of these factors on housing prices. This provides the a quantitative way to predict prices based on their variables. Finally, in the recommendation system, I scored and ranked towns based on house prices, broadband connectivity, and crime rates using weighted criteria. This approach offers actionable suggestions for choosing towns that are safe, affordable, and well connected. This is the core for the recommendation system. I'll run it, and yeah, these are the recommendation data town. These are these regions, average price, and so on. Thank you.